Alright, guys, you are welcome to the continuation of the lecture series on information retrieval. Again, we're looking at the definition of information retrieval. We talk about processing, indexing, and retrieval of textual document. We can see that in when you're searching a page on the World Wide Web. We're mostly concerned with retrieving relevant document to a query. And at the same time, because we have a large collection, we want such that it will be the system will return results in a timely fashion. So let's look at a typical I/how task. Say for instance you have a corpus, and when you say a corpus, we mean a collection of documents. So you have a corpus of textual natural language document. Say you have just like you have files in offices. So in this case, our files are digital files that we have on our computer system. So the easiest way is, let's say you have scientific literatures, papers that are published in journals. So a user query in the form of a textual string, and say for instance you have a corpus of scientific literatures, and you want your interest is on papers that are on machine learning. So what do? Your query will be machine learning papers. So we want the IR system to return a result with a rank set of documents that are relevant to machine learning. So some of the key terms that we often hear in information retrieval is a query, and that is an expression of what the user wants from the document. It could be a list of words, or it could be a phrase. So sometimes it could also be a question, like in a question answering system. The document is that contains the information that the user wants to return. And the collection, like I said before. Now you have what you call index. That's a representation of information that makes querying easier. Just like in a typical traditional library system, you have what you call the catalog, whereby in the catalog you have the author and the location of the textbook in the library. So index helps us to be able to map each document to a unique value for easier retrieval. Then term could be in a document, or it could be in the query. So term is that word. For instance, I said machine learning. So machine and learning, it's a term that is in the query, which we expect it to match a document. So let's see a typical IR system architecture. So in this case, this is our information retrieval system. And to be able to develop this system, we need to feed some input to it. We need to feed it some document corpus. And so it has in this system, the system has a way of identifying and locating several documents within its repository. So the user now comes in and input a query. So this black box is supposed to take the query from the user and do some form of processing and consult its repository of document and return back to the user a number of documents in a hierarchical order based on how the system thinks the documents are important to the user. So in a web search, you have the application of the information retrieval to HTML document. So when you go on the website and you're searching for information, the only difference is in a World Wide Web setting, you need to assemble a document corpus by spidering the web, that is crawling the web. So there are a lot of work that are being done by search engines like Google search engine, Bing, DuckDuckGo, Yahoo search engines. And what the search engine does is that They regularly at certain designated intervals crawl the internet to be able to index documents that are resident in several servers across the globe. So they do this even before the user come in to enter in a query. So it's done on a scheduled basis. So once they already crawl the web, which is also referred to as spidering the web, they have a way of indexing all the document and kind of building a hierarchical structure within their own database. So this document around the world yet continuously change. So you can then exploit the structural layout information in HTML and exploit the link structure of the web, as we'll see more when we get to page rank uh, analysis, page rank algorithm. So let's say a typical web search system. What happens is you have a crawling system that crawls the web. The web consists of HTML pages that are linked across the globe. So once it's crawled, the output of the crawling of the web is a list of documents fed into the IR system for indexing. Then the IR system waits to receive query from the user, and the IR system returns the results, rank result back to the user. It's just like when you are building a library catalog system. The process of crawling the web is where you actually feed into your library software system management software the information about the books and the locations. You have that indexed in the library software. Relevance is another important terminology that you often hear about in information retrieval, and essentially this is talking about how close, how well the information returned by the IR system matches the user's interest. So, is it on the proper subject? If the user is looking for machine learning, does it actually return machine learning papers? Is it timely? So that has to do with, is it not returning information that are obsolete? Is it authoritative from a trusted source? How do you know that the information returned is actually is not a fake? Yeah. Does it satisfy the goal of the user? How do you measure that the user actually got what the user needed, or the user is disappointed? Because that's the most important of all. If you build any IR system, no matter how good, how efficient it is, if it doesn't meet the need of the user, then it doesn't worth it. So the intended use of the information is very critical. So the main relevance criterion and IR system should fulfill the user information need, and that's what I just said. Okay. What are the basic information retrieval approach? You have the keyword search. So the simplest notion of relevance is that the query strings appear verbatim in the document. And what is that saying? Now, the user inputs a query. The query consists of terms. So, if the terms in the query appears verbatim in the collection of document, then you can just return that document as an output, as a result to the user. So there's a match. The user enters in his query machine learning, and you have document in the corpus that contains the terms machine learning. Then that's a match. You just return that. But what about if there are no terms in the document that contains, if there are no there are no documents in the corpus that contains the term machine learning. So what should happen? We will see that as we go on. So slightly less strict notion is that the words in the query appear frequently in the document. So in any order. So we say bag of words representation. Now what this is saying is this. The words in the query can appear in several documents, and it could appear more in some documents than others. And in the bag of words, we are not putting into the bag of word approach. Don't forget, we're trying to look at how to build an information retrieval system. So in the bag of words approach, we are not concerned about the ordering of the terms. So if a document contains machine learning or learning machine, it doesn't matter. So for the fact that we have machine and we have learning in the document, whether they are together or they are juxtaposed or they are even scattered apart, as long as machine is there and learning is there, we return that document, even though they are not together. That's what the bag of words approach is saying. So you can quickly see that here. You see that here. So we just go through our document and we just list out, just like giving a list of all the terms there: relations, economy, intellectual, negotiation, human, free. So we're not really concerned that, okay, rights should follow human to make human rights. We are not concerned about property should follow intellectual to make it intellectual property. So so we just want that once it has intellectual and it also has property, we're not concerned about any other. We just return the document. So for instance, on labeled data home page classification. So how does this approach work? You find words or concepts in the document, compare them to words in the query. Will this be very effective? So, just a simple approach of solving the problem of building an IR system. So, you already have a collection of the document from which you can search, and you just compare all the words with the words in the query. So once there's a match, you return that particular word. Okay. So what is the problem with this approach? One major problem with this approach is that it may not always return all the relevant document. For instance, where there are synonyms, the user might actually put in restaurant and the document available to the IR system might contain cafe. Then since there is no match, then the IR system has nothing to return, because all that the information retrieval system is looking for is cafe, and once it doesn't see cafe, then it has nothing to return. Or say for instance, the user enters PRC, which stands for People's Republic of China, but in the document all the PRC does not appear in the document. So the IR system will not return anything. Or let's say it even appears. Let's say PRC appears. Then the IR system will only return those documents that contains PRC. It won't return those that contains the word China. And by that, it will have cut away a lot of important information. important document that will be very relevant to what the user requires. Let me say upfront here that information retrieval and natural language processing are very intertwined. And the field of information retrieval is a very complex field because human needs are very complex. Most often than not, we express ourselves differently from our needs, and as a result, the computer models, computer system that we are building has, has a lot of difficulty differentiating between the way we express ourselves and what our needs are. That's the challenge we try as much as possible to solve, to minimize. It may also retrieve irrelevant documents that include ambiguous terms. So, for instance, if the user enter in bat and what you actually mean is uh, maybe a baseball, then it might return mama soup, thinking maybe you are referring to animals, or say bits, which is a unit of data, or what do you mean, or you're trying to talk about act of eating, or apple. So are you talking about apple as a company or apple as a fruit? So to resolve this ambiguity, we see the lapses of our basic IR system of just using the bag of words approach. So that's a lapse with the bag of words approach. So that's what you see here. So when somebody types in an apple on Google search, are you expecting the apple a as a company, or you also even say that there's even an apple, little apple in Manhattan, Kansas? So the system wants to know what exactly is the information need of the user, and you will see that uh, if you look, if the user is interested in Apple as a company and the system does not return Apple, or it returns Apple but it puts it on maybe a later page, maybe the third or fourth page, most users will not have the patience of actually clicking next to check. I do that most times unless I'm really ready. I may not even click next. So these are some of the challenges that we have uh, in information retrieval system. So we're going to stop here for now, and next time we will continue with how we can build a more robust, intelligent information retrieval system other than just a bag of words approach. Thank you for listening, and see you in the next one.